overlay network.
Yes.
SD fabric is an overlay
Network.
So you know that before building the SDF fabric, your underlay must be there. Your underlay must be up, right?
Yes. Right.
Like if I say this is my topology, this is my border node, this is my also border node, and I have connected a router which is my control plane node, and here I am having edge devices.
Right.
So for sure, we have a few devices here, underlying devices. Then we have this. Then devices are connected with this, and then likewise this.
Yes.
This is our complete network, but if we want to provide the connectivity directly with each other, we have to configure these switches in such a way so that they forward the traffic for our overlay network. So what we used to do here, we used to configure IP addresses on all of these interfaces.
Yes.
Because we want to keep it completely layer 3.
Yes.
So we configure IP addressing on all the devices.
Right.
Then we configure the underlying protocol. Most of the time we are configuring ISIS.
Yes.
Right?
Right.
After configuring ISIS, you know that for the control plane traffic, we are using Lisp.
Yes.
And this is the control plane node. So when I'll talk about Lisp, then I'll make it clear that what is control plane node, what is the responsibilities, and what we call it, right? Because Lisp is also having its own naming conventions.
Yep.
ETR, XTR, ITR, ingress tunnel router, egress tunnel router, map server, map resolver. We will talk about it later on. But right now, what we will be doing, like this is my edge device. So edge devices will be having a RLOC, which is known as route locator, right?
Right.
So what edge device will do whenever a device will be connected to the edge node, this device must have an IP address. Either it will have an IP address or it will get the IP address from DHCP server. So for example, IP address is 10.1.1.10 and RLOC is 1.1.1. So what as one will do when this user will get connected to this, as router will send a map registration request to control plane node. And in the Lisp database, you'll have an entry that 10.1.1.10/32 is reachable via 1.1.1.1.
Yeah.
If we have one more user here, 20.1.1.10, for example, and RLOC for this as is 4.4.4.4. So this control plane device will be having an IP address also, for example, 10.10.10.10. Now when this user will get connected to edge device have to send a registration request to control plane node. But for that, edge device must be reachable to it, right?
Right.
And who is providing that reachability? The underlay.
Yes.
So again, again your edge4 will send a registration request to control plane node that 20.1.1.10/32 is reachable via 4.4.4.4.
Yes.
First of all, they'll do it like this. When if this user wants to ping 20.1.1.10, then this request will go to as. Now as don't know how to reach 20.1.1.10, then as will send a
Map
message to control plane node again, map resolver.
Okay.
Right? Then it will it will tell that the route locator for this is 4.4.4.4. So as device will also get the entry that 20.1.1.10 and Our locator is 4.4.4.4.
Yes.
This is the role of control plane. Now, while we will be forwarding the data plane, and that time we will be using VXLAN. And this would be the original packet. Like source IP is 10.1.1.10. Destination IP address would be 20.1.1.10. But a new VXLAN header will be added to this packet.
Yes.
A new VXLAN header source IP address is 1.1.1.1 and destination IP is 4.4.4.4. There are other things also present in the VXLAN header. We will be discussing it later on. But this is how as we'll forward traffic direct to this else.
Yes.
Right?
Yes.
Again, who is providing the reachability information from 1.1.2 to 4.4.4? Underlay.
Underlay.
But the underlay will not be responsible for the end-to-end data delivery because these devices are not having any information about 10.1.1.10 or 20.1.1.10. Right? That's why we are double encapsulating it.
Site table. Oh.
All right, Nitesh?
All right.
That's clear?
Clear.
Okay. So next, we can start now. Just 1 second. Let me open a document that we can get the reference only. Can you see the screen, Heather? Nitesh? Hello? Hello? Nitesh, are you there?
Yeah. Yes.
Okay. Can you see the screen?
Yes, I can.
All right. So in last class, we have discussed about control plane node, right? In control plane node, then I've shown you the devices that which device can perform as a control plane node. Because what is required? Lisp support is required.
Right.
These are the platforms or these are the devices who can act as a control plane node 9300, 9400, 9500, 9600. Then we have 3000, 6000 and ISR 4000 and ASR 1000. And we will be seeing this configuration when we'll do what? When we'll configure SDA fabric. At the time of SDA fabric configuration, you will be assigning the role to a device. All right.
All right.
You can see here control plane, border node, and edge node. There are only 3 roles present because this is a switch.
Right.
If you add a WLC, you will see the capability of wireless, or you can say WLC also. All right.
Right.
And the fun fact is that single device can be configured to perform as control and border node both. All right.
Okay.
Yeah. If you have a very big network, you are supposed to have separate control plane and border nodes. But you can integrate the operations of control plane and border node on a same device.
Okay.
Sometimes.
Can there be high availability as well?
Yeah, they can be high availability. You can add more than one control plane node, and then at that time you have to define the priority value so that which control plane node will be preferred first. Okay. Yeah. And one more thing that you can configure a single device as a edge node, border node, and control plane node. All right.
Okay.
You know, sometimes we have very smaller sites, very
Smaller side.
smaller site. So a single switch will be configured as control, border, and
Right.
sometimes this kind of thing is known as fabric in a.
Box.
See, we have seen that a fabric is a combination of there are multiple types of devices, but when you have configured a single device to perform role of all the type of nodes, that thing is known as fabric in a box. Means the whole fabric existing in a single box. All right, in this,
Right.
and we are calling box to this device who is acting as control, board, and all of this. We will be discussing it later on. You'll see it, no issue. We'll go through the theory part as soon as possible, and then we'll move to the practical one. Okay.
Sure.
Yeah. All right. Then we have the as node. Right. We have also covered the as node in last class, as long as I remember.
Where
So
then
just for a quick revision, as node is responsible for identifying and authenticating endpoints, right?
Right.
Because as we have, you know that we always listen this from our elder ones, like mother and father are the first teacher of a
Right.
child, right?
Right.
Likewise, whenever a device will be trying to part of the network, first of all, that device will be introduced to the as node, right?
Right.
Whenever you will be try to get connected in the network, first of all, you will go to the as node. Now, this
Yes.
as node is responsible for what? Is responsible for authenticating this device.
Right.
Because this is the first touch point, right?
Right.
So responsible for identifying and authenticating endpoints, static 802.1x or active direct.
But the edge nodes will not communicate directly with the radius, right?
Who?
But the edge node will not directly communicate with the ICE. It will be through the DNA center itself.
Yeah, it will be, but always
But this
remember
is
that your as node must be reachable to ICE. Okay. And register specific endpoint IDs means Lisp. When this user will get connected to the as node will send registration request to, sorry, note this, because this is a border node, to this control plane node. Provide an anycast layer 3 gateway for the connected endpoint, same IP address on all as nodes. Because you know that default gateway is required to a user whenever he wants to communicate with external networks.
right.
And in traditional network, we used to configure, HSRP
Right.
on distribution layer switches. Now we don't have any distribution layer switches here.
Right.
So we are not going to configure HSRP anywhere in the network. We will be doing what? Each as node will be having the same IP address on the SVI interface, which will be acting as the default gateway for end users.
Right.
Okay.
Right.
And perform encapsulation, decapsulation of data traffic to and from all connected endpoints. When the user will connected here, the user will be sending the original IP address. But this IP address is not available to the underlay devices. So we need to encapsulate this IP address with another IP header in which we will be encapsulating RLOCs, routing locator IPs. Then you know that SD access platforms 9200, 9300, 9400, 95, 9600, 3000, 4500 and 6000. Okay.
Okay.
You can see that at this point you can configure it as node. Fabric components and terminology part 2. Now we are talking about border node. All right.
Right.
So you can see that border node is an entry and exit point for data traffic going into and out of the fabric. That's why
Right.
we call it border. Like countries, border between two countries.
Right.
So this border point is entry and exit to get into a country. If you want to get into a country, you have to go through the border. You can exit through the border. So entry and exit point for data traffic going into and out of a fabric.
Right.
See, end user is a part of fabric, right?
Right.
But Google server is not part of your fabric. In order to reach Google server, you have to go out of your fabric zone. So who is
Right.
going to help you to get out of your fabric zone? The border node itself, right?
Right.
So border node will send the traffic to the border node, and border node will forward the traffic to ISP or whoever he wants to forward the traffic.
Right.
But here in the SD fabric, we have types of borders.
Mm-hmm. Okay.
Here we have the types of border node. So basically, we have three types of border node. You can see internal border, rest of company. Connects only to the known areas of the companies.
Okay.
Second is connects only to unknown areas outside the companies. And third one is internal plus external. Connects transit area and known areas of the company. Now
Okay.
see what's the difference here. These are the platforms who can perform as a fabric border node 9300, 9400, 9500, 9600. 3000, 6000, 7K, ISR 4K, and ASR 1K. Now you can see that Nexus 7K can perform the role of border node. Okay.
Okay.
At this time, you can configure as border node.
Right.
Now see, first of all, internal border. Advertise endpoints to outside and known subnets to inside.
Right.
See, this is a border node, and you have your own network here as well. Switches, servers, all right. So connects to any known IP subnet available from the outside network. For example, data center, WLC, or firewall. Because firewall is not part of the fabric,
Yes.
but firewall is the part of your own network.
Yeah.
Data center, because for example, you have access points here, APs.
Right.
And now WLC can be deployed in two types. WLC can be in fabric or not in the fabric.
Okay.
Not in the fabric means that your WLC is not located as a part of your fabric. It is located outside of your fabric, but it doesn't mean that it is located in the internet. It is located in data center, for example.
Okay.
So this access point will be going to the WLC through which router? From
Border.
which device? Which border?
Internal border.
Internal border. All right.
Okay.
exports all internet IP pool to outside as aggregate using a traditional IP routing protocols. Now you have you have IP subnets here. So all of the IP subnets will be advertised to the data center and to firewall and to WLC.
Okay.
And you know that it will automatically aggregate. It means
Okay. Summarization.
summarized.
Okay.
Now you can see that the last point, sorry, the next point is import and register known IP subnet from outside into the control plane map system.
Okay. So
Because
this one.
you have WLC here, right?
Mhm.
This as node, and this is the AP. AP
Right.
will go to as node, and as node will not go to border node directly. As node will go to
Controller.
control node that I want to reach this IP address.
Right.
The border node is also having a RLOC. So now border
Right.
node is responsible to provide the mapping of WLC to the control plane. So import and register known IP subnets from outside into the control plane map system. So that whenever it needs to reach the WLC, control plane will see, okay, to reach the WLC, you should go to this border node.
Right.
Then traffic will be forwarded to border node and border node will give this traffic to the WLC side.
Right.
Okay.
Correct.
Yeah. Handoff requires mapping the context VRFL from one domain to another. Then you can think of it like this: internal border
Okay. Yes.
connecting to branch office as well as connected to
Data center.
data center. SD access border deployment, anywhere border, SD access as a transit area. Then you have the external border. External border is a gateway of last resort for any unknown destination like Google, Facebook, Instagram, Gmail, Yahoo.
Like the internet itself.
Yeah, like the internet itself. Very good. So it external border here connects to any unknown IP subnet outside of the network, internet public cloud. Export all internet IP pool outside into traditional IP routing protocol as aggregated. Does not import unknown routes. It is a default exist if no entry is available in control plane. So basically, while you are deploying this external border, make sure that this external border is sending a default route in the domain.
Okay.
Default. For example, IP address of this route locator IP is 4.4.4.4. So this border node will create an entry to control node that 0.0.0.0/0 4.4.4.4.
Okay.
That if you don't get the exact information, go to border node and it will forward the traffic out of your network.
Okay.
You can see it here. Public cloud and internet. All of these networks are
Unknown network.
unknown networks. So if I show you the DNA center, we haven't discussed it yet, but no worries. I'm just showing you the discussed part 192, 160, 2.1. Okay, I think it is of 50. Okay, I need to turn it on, but that would be taking around 30 to 40 minutes. All right. So you can
So
see
the
that this external border, which border is this?
external.
External border. This external border is connected to public cloud as well as to the internet.
Right.
This is something you need to take care of in the network sometimes, that if you have only border node,
Mhm.
which is external border, only external border if you have. So now we have WAN as device and this DCS. So WAN as is connected to WAN branch and DCS is connected to data center. But you have only one, if you have only one external border, then your traffic will be going to this on the behalf of default route. Then this border node will forward traffic to edge for this and to this as towards data center.
Okay.
All non-fabric traffic must travel to the external default border. If other internal border WAN or DC are only reachable via the same IP network, traffic may follow a suboptimal path.
Mhm.
It is saying that if you have only deployed, if you have only if you have only deployed which border
External border.
and this as node which is the part of fabric and these are not part of the fabric, you can say out of the fabric,
Yes.
right?
Right.
In this case, as node don't know how to reach all of this WAN as or DCS, so what they will do, they'll send traffic to the external border and then external border will send back to WAN as WAN or DCS.
Okay.
So instead of doing this, they can go directly to them, right?
Right.
But the problem is you have only deployed,
External border.
this is known as suboptimal path. You know that we have two types of routing, optimal routing and suboptimal routing. Suboptimal routing occurs when you have best path, but you are not following that best path. You are taking a longer route, right?
Right.
See, you can deploy these two switches as internal border. If you will deploy
Mhm.
these two switches as internal border, traffic will not be going like this.
It will be optimized.
Traffic to internal domain will go directly to the internal borders.
Right.
And any traffic, any external traffic, for example, internet,
Go
can
to
still
the
exit by the
external border.
external border. Yes.
Clear.
Any confusion here?
Clear.
No. Okay. All right. Okay. So that's why it is that it is better to deploy internal border routers as well.
Okay.
Right, Nitish?
Right.
Okay, where is the internal plus external border? Yeah, it is here, I think. Yeah. We have three types of border, right?
Yeah.
We have three types of border node. First is we have internal border, we have external border, we have internal plus external border. Connect transit area and known areas of the companies both. So here it is any bare border. SD access as a transit area to reach the external borders or to reach the internet. Because sometimes we have the fabric
Mhm.
in which we do what we send the traffic through the data center towards ISP.
Yes.
Because we don't have a thing which is known as direct internet access.
Okay.
So in those cases, what you will be doing, this is for example data center, and for an instance, okay, let me take it from here.
Okay.
Can you see this?
Right. I can see.
Right. This time we don't have this connectivity here, Nitish.
Okay.
And we can say we have connected to the internet through
Data center.
data center. This time this router is, or this switch is acting as internal border because this device is helping me to reach my internal networks.
Right.
But this time this internal border will be acting as
Internal and external.
external border as well. So this time this device is acting as internal border and external border both.
Right.
Right. So we have three
Right.
types of border now. We have internal border, we have external border, and we have internal plus external border.
Right.
And when we'll see the GUI of the DNAC, or when we will add the device, you will see this option. Where is that option? Yeah. Do not import. What happened to this? Okay. You can see it here.
Right.
Default to all virtual networks. And second, do not import external routes to inside. After this, is it clear?
Right.
Border nodes?
Right.
Any confusion? Let me know.
It's okay. Yeah.
Now see, the next is we have fabric enabled WLC.
Within the fabric.
So you can have two types of WLC, Nitesh.
Yes.
Fabric
One
enabled WLC and out of the fabric WLC.
Okay.
You know what is the problem with out of the fabric WLC? Basically, if I talk about the traditional network,
Right.
this is my distribution 1, this is my distribution 2, this is my access 1, and this is my access 2.
Right.
And here I'm having an access point AP1, and here I'm having access point AP2.
Right.
Both of these APs are lightweight APs.
Mhm.
Lightweight AP means they have a WLC here. So when they have the WLC here, first of all, after discovering the WLC, they will build a
Kappa tunnel.
cab wrap tunnel.
Right.
The cab wrap tunnel, and this AP will also build a cab wrap tunnel.
Right.
So now cab wrap tunnel is acting as overlay network,
Yes.
right?
Right.
So this is our cab wrap tunnel. Control and provisioning of wireless access point. All right.
Right. Right.
And this cab wrap tunnel is using a protocol which is known as DTLS, data transport layer security, which is helping us to encrypt and decrypt the information. Now, this cab wrap tunnel is responsible for forwarding both type of traffic, control plane traffic and data plane traffic. Control plane traffic and data plane traffic. Any traffic, any traffic which is related to the management of APs will be going through this tunnel, as well as if you have one user here, and if you have the second user on this AP2, this user will send this traffic to the AP will send this traffic to the WLC through the cab wrap tunnel, and then this WLC will forward this traffic to this AP. So all the data plane traffic will be also going through the WLC, which is taking a longer path, right?
Okay.
It happens in which networks?
Yes.
Traditional networks.
Right.
Again, see, this is your choice. This is your choice, Nitesh. You can still deploy your WLC out of the fabric if you want, right?
Yeah.
And the same thing will happen again. If you have deployed the WLC out of the fabric,
Got it.
out of the fabric, so the access points will not be able to advantage of the the access points will not be able to take advantage of the VXLAN and Lisp overlay network, because they will not be using this. They'll be forwarding traffic through the cab web tunnel all the time, right? So, but in this case, you can see that right now it is showing you that WLC is part of the fabric.
Right.
What happened to it now?
So within the fabric, the WLC will just manage the APs.
Yeah.
But if it's outside, it will manage both the traffic, data, and the controller.
Yes. You can see it here. Let me copy them. Can you see it now?
Yes.
Yeah. So Fabric enabled WLC is integrated into Fabric for SD Access Wireless clients. Connect to Fabric via border known as underlay. Fabric enabled APs connect to the WLC through cab web tunnel using a dedicated host pool. Fabric enabled AP connect to the WAN as via VXLAN. Can you see it now?
Yes.
Here.
Yes. Yeah. Yes.
Right?
Right.
You can see it here now. The control plane traffic is still going to the WLC using the cab web tunnel. All right.
Right.
But this AP is connected to the switch using VXLAN.
Mhm.
So now this is the responsibility of your WLC to do
So,
what?
so right now it needs two cables or two physical cables, or it will be one physical cable itself.
So there is only one physical cable. This is the virtual connectivity.
Mhm.
All right.
Okay.
Now, if a user will connect it to this AP,
Hmm.
this AP will send this information to
WLC.
WLC. What WLC will do? WLC will create entry of that IP, user IP, with this as device. For example, this as is 1.1.1.1 and user name bar is, for example, A. So this time you know that AP is not sending registration request to this control plane. AP is just telling the information to WLC that we have a new user. So
Mhm.
what WLC will do? WLC will create a
Map request.
map request to the control plane. So that
Right.
when user will be sending the actual data, AP will connect it to the as device through VXLAN. And for that VXLAN, we will send again
Right.
request to resolve the IP
Okay.
address.
Okay.
Okay.
Right.
So wireless client
Right.
use regular host pool for data traffic and policy, same as wired. All right.
All right.
Fabric enable WLC register clients with the control plane as located on
It
local as plus
access point.
access point. All right.
Okay.
So your WLC can deploy it in the SDA fabric. At this time, this is how it will behave. Then
So when the WLC is within the fabric, this WLC cannot communicate with APs outside the fabric. Like for example, like a remote site, a branch office or something, it cannot communicate that.
if you have deployed WLC in data center, in that case, you have to configure the access point as Flex Connect
Mhm.
so that they can locally route the traffic.
Okay.
They don't need to go through the WLC all the time, okay?
Okay.
But yes, WLC can be deployed in data center networks as well.
Okay. We'll see.
All right.
Okay.
Yeah. Now you can see that Fabric enabled wireless. You have Air OS WLC. Right now we have stopped using this. We have the Catalyst 9800 with robust capabilities. So we are focusing on this 9800 nowadays. And you know what? If you have uh, if you have a 9500 series switch, that switch
Mhm.
is having the capabilities of WLCs. You don't need a separate WLC. You can configure your switch as a WLC as well.
Is it license based or
Yeah, license is required, but you have to upload one image also, which is known as embedded wireless or embedded WLC. So you have to add that image to the switch and then you have to enable it as WLC as well. So switch is also capable of do the task of WLC. Then you have Wi-Fi 6, double AC Web 2 AP and Web 1 AP as part of the fabric. You can see while you will be adding the WLC, you have to use which thing? Wireless. If you will click on this, it means you are deploying the WLC in the fabric. If you keep it unchecked, it means you are deploying the WLC out of the fabric.
Oh.
Okay.
Yes.
Fabric components and terminology part 4. Okay. SD access extension for IoT. You can have the cameras here, scanners. So you can see operational IoT simplicity, automation, IT design and managed, IT design and OT managed. Greater visibility of IoT devices, which is known as assurance. You know, assurance is a power of your DNA center.
Okay.
And Cisco has a separate book for assurance feature only. Like what is assurance, how it works, how it collects the information, how it can be optimized to achieve the best performance, all of these things. We will be covering assurance part. Now, next thing which comes is virtual network.
Data plane.
If you remember that we have discussed the services of DNA Center. At that time, we have seen one service which is known as
Segmentation and security.
segmentation.
Right. Right.
In today's networks, VLAN is the only option to create
Segmentation.
virtual network, right? Or you can say create segmentation.
Right.
VLAN has its own shortcomings. So we are only dependent on VLAN to create the network segmentation,
Right.
right?
Right.
So just a second. See, network segmentation. Look at some of the options available today and their challenge for creating network segmentation. What kind of network segmentation tools are available today? First one is segmentation using
VLAN.
VLAN. The simplest form of network segmentation relies on VLANs. You may not be used to thinking about a VLAN as network segmentation technology, but that is what a VLAN is. Why the book is saying this? Because you know that whenever you learn VLAN in CCN or CCNP, right?
Can you hear me?
Whenever you learn about VLAN,
Hello.
hello,
Yeah.
can you hear me?
Yeah. Yeah. I can hear.
We have the internet issue actually.
Okay. Okay. Sure.
All right. I hope you can see this, right? Hello?
Yes.
Yeah. See,
Right.
whenever you learn about VLANs in CCNA or CCNP, the instructor always teach you like this, that this is our switch, right?
Mhm.
All ports belongs to the same VLAN. So we have a very large broadcast domain.
Right.
In order to divide the broadcast domain, we can create VLANs.
Right.
But if we see the other aspect of VLAN, what VLAN is doing actually, VLAN is segmenting the network. Or VLAN is creating virtual networks inside a big network, right?
Right.
This is why the book is saying that you may not be used to thinking about a VLAN as a network
Okay.
segmentation technology, but this is what a VLAN is.
Yes. It is.
A segmented layer 2 domain. By placing users and devices in different VLANs, traffic controls can be enforced between them at the layer 3 boundary. For wireless, different SSID might be used for separation into the air, but then these are mapped into VLAN on the wired side. See, if you have our configured wireless networks, so when you will be configuring SSID, you also have to bind the SSID with a VLAN ID.
Right.
So if you have three SSID, for example, SSID 1, SSID 2, SSID 3. These SSID are separating the wireless network on the air. But when the traffic will come to the wired network, you have to use VLAN. So I've given VLAN 10 to SSID 1, VLAN 20 to SSID 2, and VLAN 30 to SSID 3. Okay.
Right.
For wireless, different SSID might be used for separation into the air, but then these are mapped into VLANs on the wired side. The challenge with VLANs as a segmentation method is twofold.
Right.
Their span and the topology related issues they bring along with. Hello? Hello?
Yeah.
Can you hear me,
Okay.
Nitesh?
Yes, I can hear.
Okay.
Yes. Yes.
So basically, the challenge with VLAN as a segmentation method is twofold. Their span and the topology related issues they bring with
Yes.
them. First thing is the scalability issues, and second thing is the broadcast problem. In terms of span, most organizations choose to constrain VLAN to a relatively small area, often limited to one wiring closure. Because of this, many organizations end up managing hundreds or even thousands of VLAN in a typical deployment,
Breaking.
making IP address
You're
planning.
breaking.
What?
Your sound is breaking.
Okay, just give me 1 minute. Let me.
Yes.
Hello?
Yeah.
Can you hear me now?
Yes. Clear.
Okay. So you can see here, first problem is with the VLAN spanning. Key challenge with using VLAN including the following. Give it a read by yourself, Nitesh. It will be more clear to you.
Okay, sure. Widely spanned VLAN is vulnerable to layer 2 sharing redundant network, and thus are risks of meltdowns if an uncontrolled layer 2 loop could be occur in the region. The large layer 2 designs are very insignificant. 50% ports blocking typically. Traffic filtering options in intra-VLAN are also typically much more limited than those available. Clear. Yes.
Right?
Right. These points are correct. Right. First one is looping. Second one is you will not reuse all the ports effectively due to STP. And inter-VLAN routing has limitations when applying ACLs.
Yeah.
Clear. Clear.
So, right, that's the problem to create the network segmentation using the VLAN.
Right.
VLAN are simple, but in this case, simple is not best. A flat layer to design expose the organization to too many potential events that could take down the network, and in addition, managing hundreds of VLAN is daunting for most organizations.
Right.
That's why we come up with VTP and all that things. What
Right.
VLAN trunking protocol, server, client, transparent.
Right.
Second, we are creating the segmentation using VRF. Like we have already discussed this thing, but just to, for a quick revision, I'm telling you. First thing is we are using the VLAN. Second thing we are doing using the VRF Lite.
Right.
But the problem is VRF Lite with VRF Lite is that with VRF Lite you need to specify the VLAN ID again.
Right.
So another approach, one that leverages layer 3 is to segment the network by using VRF, essentially separate versions of the IP routing table. Because by default, if you have a router will be having a single routing table.
Right.
Single routing table.
Right.
But by creating VRF, you can create multiple routing tables on this router. This has the benefit that segmentation can be provided without the need to build large, complex ACLs to control traffic flows. Because if you
Yes.
have two VRFs, by default, inter-VRF traffic is not allowed.
Yes.
You don't need to create thousands of ACLs to block the traffic. Since traffic between different VRF can only flow as the network manager detects by the network topology. See, inter-VRF communication will not be possible if you will not interfere. You can provide
Right.
inter-VRF communication, but for that you will need to configure route leaking. Like from one VRF
Yeah.
routing table to another VRF routing table.
Right.
But the problem is challenges with VRF. VRF Lite using 802.1 queue trunks between devices is relatively simple to implement on a few devices, but becomes very cumbersome very quickly when implemented more widely. For example, this is R1,
Okay.
this is R2,
Okay.
this is R3, this is R4, right?
Right.
R5 and R6. So if you want to create the VRF here, first thing is you, for example, this is VRF A, this is VRF B. Again, this
Right.
is in VRF A and this is in VRF B.
Right.
So if you want to provide communication from R3 to R6, you need to configure VRF on this interface as well.
Sub interface.
You need to create sub interfaces here, right? For VRF A and for VRF B.
Right.
VRF A and VRF
Right.
B. So when you'll create the sub interface, at the time of sub interface, you know that if you'll not define the VLAN ID, you would not be able to configure the IP address. So first
Yes.
thing you will need to define a VLAN,
Ideally.
then you will be able to configure the IP address, right?
Right.
So it seems very easy, but for only smaller networks. If we have large size networks, then it would be very difficult.
Yes.
Okay. Then we have the VRF Lite requires separate routing table processes per VRF, again, which is resulting in CPU load and
Yes.
the typical rule of thumb is that VRF Lite deployment should not be scaled beyond 8 to 10 VRFs.
Mhm.
as they become far too unwieldy to manage end-to-end in an enterprise deployment at a larger scale.
Right.
Okay.
Correct.
Yes. That's why this idea is not also valid. Segmentation using MPLS. Yeah, MPLS is a better choice in comparison of other things. As
Yes, you are correct.
alternative technology available for network segmentation, MPLS VPN has a steep learning curve since they require the network manager to become familiar with.
Need to support. The devices need to support.
Yeah, first of all, the device needs to support, and before that, if you are the network administrator,
Mhm.
you should know the in and out of MPLS.
Right.
If you don't know the in and out of MPLS, you would not be able to configure it correctly.
Okay.
So the knowledge of MPLS is also required. But you know that if you have the DNA Center, you don't have to learn the technologies in depth because all of the things will be done by the DNA Center itself.
Automated.
Yeah, that's why we call it IBN.
Right.
Intent based means your intention must be clear. Leave everything else on the DNA Center itself. Right?
Right. Right.
Yes. So this is how we were creating the segmentation in traditional networks. We are using VLAN, or we can say we are using VRF line. Right?
Right.
How it is done in today's network? Let me show you. See, first thing, virtual network. Virtual network maintains a separate routing table and switching table for each instance. Maintains a separate routing and switching table for each instance. Control plane uses instance ID to maintain separate VRF topologies. There's a default VRF with instance ID 4098. See, at the time of fabric building, you can define the virtual networks. So now you can see that we have VN campus, we have VN IoT, and we have VN guest. I'm not using VRF and I'm not using, sorry, we are using the VRF, but we are not using the VRF light. We are using VRF here,
Right.
and plus we are not using VLANs at all.
Right.
Nodes
Right.
added a VN ID to the fabric encapsulation. Virtual network identifier. When the host will come into the picture, host will be added to one of the VN, either VN campus, VN IoT, or VN guest.
Yeah.
You'll see how this is dependent on the authentication, how the user will be authenticated. As per that, the user will get the virtual network.
Intended virtual.
Yeah. Endpoint ID, which is known as EID. EID prefixes or host pools are routed and advertised within a virtual network. Host pool of this VN will not be going to this VN or this VN.
Right.
Use standard VRF definition configuration along with RD and RT for remote. See, the configuration is same. When you need to create VRF, you need to do it like this. VRF definition, and VRF name, right?
Right.
But this time we will not be creating the VRFs manually. VRFs will be created through the DNA set.
DNA set.
All right.
All right.
Then further division. Fabric devices underlay connectivity is in the global routing table. You know that, right? Because overlay is built on the underlay. So underlay networks are still belongs to the global routing table. Okay.
Yes.
This still belongs to the global routing
Routing.
table.
Right.
Infra VN is only for access point and extended nodes. Default VN is an actual user VN provided by default, and user defined VN, sorry.
Okay.
These are default VNs, but you can also define VN by yourself.
Okay.
So you can see there are 4 types of VNs. First is,
so the first 3 are default,
yeah,
and the
the
second
global
one
VRF,
inter virtual system, virtual network, and default. Okay.
yes. Okay.
Okay.
And last one is user defined VN.
Yes.
So you can define VN as per your choice or as per your requirement.
Okay.
Yeah. Okay. So this is how the VN works in the SDXs. SDXs design connecting to existing global routing tables should use a fusion router with MP-BGP. This is something which is used at the time of Fabric. But right now, let me give you explanation that how it works basically. SDXs designs connecting to existing global routing tables should use a fusion router, means that this part is not having any fabric thing. So this router is known as fusion router.
Okay.
You know, this fusion router is also used at the time of building a fabric. The border node will not be connecting directly to the ISP or to the MPLS. We will have a fusion router in between. So now this is as node, this is control plane node, and this is border node. In underlay, I'm using ISIS.
Right.
And we have VRF-V and we have VRF-A. So you can say SPI-B, SPI-A, and we have the interfaces likewise this. Then we have address family IP version 4 MP-BGP. Basically, this is what this is.
Global routing.
Global routing table. Now you can see that on this side we have IP VRF users and IP VRF default VN. So in VRF, you need to define two values, which is known as route target,
route distinguishing.
RT and RD, right? Then we
Right.
use these values to import and export the prefixes.
Right.
So route distinguisher and route target.
Right.
Now you can see that in IP VRF global VRF we have imported 4097, we have imported 4097, and we have exported 4097 both, and then 4098 and 4099. So IP VRF user and IP default VRF PN introduced in the global VRF.
Right.
You can say the global routing table. And we will be creating these VRFs DNA.
Okay.
Yeah. Configuration is something different. Now scalable group. Remember SGT?
Yes.
See, in last class, I've told you that SGT is stand for security group tag, right?
Yes.
But no, that's not true. Basically,
It was scalable.
see, the concept is same. While we are using it SGT in security, at that time we call it security group tag.
Okay.
But now we are using the same funda of security group tag in SD access. But we have renamed it. We call it now scalable group tag.
Okay.
The working, the meaning, everything is same, but we have just changed it the name as scalable group tag. Means this time we are using it in
SD access.
SD access, and if we are using it simply, then we call it security group tag.
Okay.
Now you have a VN, you have a virtual network. Okay.
Okay.
In this virtual network, you have types of user. So at the time of first or second class, we have discussed about two types of segmentation.
Macro and micro.
Macro
Macro for
segmentation and micro segmentation, right?
macro for VRF and micro for SGT.
Yeah. Macro means that at the large scale,
Yes.
VRF. And if you want to segregate the number of users again, then you can use SGT, scalable group tag.
Right. Right.
Right? Nodes uses scalable group to ID and assign a unique scalable group tag to endpoints. Nodes add a SGT to the fabric. Encapsulation SGT are used to manage address independent group based policies. Edge or border nodes use SGT to enforce local scalable group ACLs. Now you can see that you have defined SGTs, SGT3, SGT7, SGT23, right?
Right.
You need to configure an access list. You're not going to define the access list on the behalf of IP address this time. You will say that source SGT. Source SGT is 3. Destination SGT is, for example, 23. So you have to do what? You have to permit TCP.
Right.
It's port number 443. Then I said deny ICMP from source SGT3 to destination SGT 23. So it will deny the ICMP traffic from source SGT2 to SGT23.
Okay.
Now you have a user here. All right. When this user will connect to the network first time, the edge node will perform what?
Not running. Not one.
Once the 802.1x authentication will be completed, a security group or scalable group tag will be given to this interface, means to this user.
Right.
All right.
Right.
Now, it is saying that the control plane or border node or as node will be configuring the access list. It means if this user is sending traffic, the tag must be carried
Right.
in the traffic so that border node can configure ACL on the basis of that SGT, right?
Right.
So that's why you will see that VXLAN is having a field to carry the SGT, to carry the SGT.
Okay.
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 Yeah. Any confusion here?
Okay. Yeah.
All right.
So within within the edge nodes, we can configure within the edge nodes and within the border nodes, we can configure the scalable access list,
No,
scalable
see,
group.
the scalable group tag will be provided by the ICE at the time of 802.1 access authentication. All right.
Right. Right.
But we need what we have to carry that SGT in the packet.
Right.
So that border node can take decision on the basis of that.
Right.
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 That's why in VXLAN header, we have a field to carry SGT information.
Okay.
Okay.
Right. Right.
Yes.
No, I was just talking about this access list which we mentioned, permit TCP, source HTTP, that access list. So this one is enforced in the edge devices, right?
Yeah.
There is access list.
What you said, Nitesh?
The access list which we mentioned right now, permit TCP, source HTTP3,
Yeah.
destination. This is implemented in the edge nodes.
Yeah, on the edge node, but the traffic will be going directly on the, yeah, if the traffic is going from edge to edge, you can configure the ACL on edge node as well, like you can see here.
Okay.
Right.
Right.
If you don't want your traffic to go outside of the border node, you will be configuring the access list on border node also, and you can
Clear.
configure on edge node also.
Clear. Clear.
All right.
All right.
Yeah. In the policy, you can create the virtual networks here. Default VN, infra VN, guest, users, all of this. Okay.
Right. Right.
Yeah. Host pool. Host pools provides basic IP functions necessary for attached endpoints. As node uses a SVI interface with IP address, which is that used as anycast gateway. Fabric uses dynamic endpoint mapping to advertise each host pool per instance ID. Fabric dynamic EID allows host specific advertisement and mobility. See, and the list, we are more focused on the host itself, not on the network.
Yeah, right.
Not on the complete network. We are more focused on the host.
Host.
That's why the you will always see in the map address or in the mapping table, the entry is created using the /32 or /128. /32 in case of IP version 4 and /128 in case of
So
IPv6. Okay.
So it is specific host.
Yes.
Even if all the what is it? Virtual networks have the same subnet, still we can segregate per host.
Yeah, the virtual network can have the same segment as well. That's why we call it overlapping subnets.
Okay.
But we are not supposed to configure an overlapping subnet in our SD access fabric because sometimes if we require inter VRF communication or inter VN communication, that would be would not be possible if you have the overlapping subnets.
Okay.
Yes. Okay.
Okay.
Yeah. Anycast gateway, like we have already discussed. In this, we similar principle and behavior to HSRP, VRRP with shared virtual IP, but we are not using HSRP or VRRP here.
We can.
See, it is not required now.
Yes.
Because now the gateway is not present on the distribution layer switches. The gateway is present in the as node itself.
Right.
So user is directly reachable to its own default gateway at every edge device.
Yes.
That's why we don't require the HSRP or VRRP anymore. You'll see that in SDAccess Fabric, you have no concept of HSRP and VRRP.
Right.
Creating fabric, then we are creating the add for okay. Fabric operations. But first of all, it should be clear with the SD access fabric components. Then we can discuss the further things, right?
Yeah.
So we have discussed this much today, right, Nitesh?
Right.
If you have any confusion, please feel free to ask.
I will review it.
Good?
I'll review it.
Yeah, that's enough for today, I think.
Yeah.
Right? We have started at
Right.
11, I think 11:40.
10:40.
Yeah, sorry, 9:40.
Yeah.
It's almost 1 hour and 40 minutes straight.
I'll review these.
Yeah. So I'll share this with you. Please
Okay.
go through it and complete it to this part till now, till this, before fabric operations. Then we'll discuss control plane based on Lisp, then data plane based on VXLAN, and policy plane based on CTS, Cisco Trust Sec. So we will be discussing that what is VXLAN, roles of devices. You can see like Lisp map server resolver, Lisp tunnel router, XTR or ETR. See, XTR is known as a router who perform both the operations. Ingress tunnel router and egress tunnel routers. Fabric operation, then control plane operation. We will be covering it in next class. All right.
All right.
Yeah. So that's all for today, Nitesh. I'll upload the video right away and please go through this PPT. Okay.
Yeah.
Complete it to this.
Before fabric operations.
Yeah, before fabric operations.
The notes.
Yeah. And I have also this is a great book, Software Defined Access 0 to 1. I can share this one also with you if you want it.
Sure, please.
Yeah, because this book is written by many engineers who have worked on the real thing. You can see this book is written by all of these people, brilliant people.
Sure.
Right?
All right.
So have a good day. Happy New Year.
Happy New Year to you too.
Yeah.
Yeah.
Bye bye. It is.
Bye-bye.